Welcome back, everyone. Today we're covering the P7 Shield Metal Arc Welding Module. There's not a lot of info in your book, so I've added some extra info into this slide so you got all the info for your test. First part here is safety. Back to basics. Ultraviolet light from welding operations is most dangerous because it burns your skin and is responsible for arc flashes. This is where PPE helps to protect your eyes and skin. I'm sure everybody knows the basic PPE. Welding helmet, filter lenses, covering up, cotton or leather. Cotton or leather is an argument that comes up on the Red Seal exam. Cotton is for cutting, leather is for welding. Ventilation is a major factor for stick welding. The threshold limit value for stick welding operations is 5 milligrams per cubic meter in an 8-hour workday. If you're working with materials that contain manganese or chromium, the exposure level will increase. WorkSafe PC regulates 10,000 cubic feet per welder, given that the ceilings in the environment are 16 feet high. Anything that generates carbon monoxide, generators and whatnot, should be taken into account as well, especially when you're working in confined space. Fire extinguishers, class A, B, C, and D. Class C for electrical fires would be the best choice for a welding machine fire. The class D is for combustible metals like magnesium, which can combust in dust form. For test purposes, a fire watch stays on duty 30 minutes after the hot work is done. Here's the summary for the safety section. Moving on to power sources. Electrical measurement. Current is the flow of electrons which creates heat. Voltage is the pressure that moves current through a conductor. In a welding circuit, current flows from negative to positive. Where you connect the ground or electrode will determine the heat input. Electrode positive, also known as reverse, concentrates more heat in the electrode. And electrode negative, also known as straight polarity, concentrates more heat in the base metal. If machines have polarity switches, this can change current flow direction without having to swap your leads. Types of welding current are alternating current, direct current electrode negative, and direct current electrode positive. The main welding power used on single and three-phase machines is constant voltage and constant current. Constant voltage has fluctuating current and a stable voltage and is usually used for wire feed processes. Constant current has a stable current and fluctuating volts and is used for stick welding and TIG welding. Here we have power differences. Alternating current power fluctuates from positive to negative 120 times per second. Direct current flows in one steady direction that can be switched from negative to positive. DC produces a smooth and easy to control arc with minimal spatter. The main drawback with DC is chances of arc blow. The arc from AC is harder to handle and produces more spatter. There are many benefits of AC stick welding, but DC is more common. This graph here shows single and three-phase power. Single phase doesn't keep up to heavy industrial use. The main advantage of AC power is that the rapid changing from negative to positive eliminates arc blow. This shows the difference between a constant current and constant voltage voltamp curve. Constant current is also known as a drooping voltamp curve. Machines have an open circuit voltage around 86 volts ready to strike the arc. Once you strike the arc, the circuit closes and volts drop to almost zero. In this brief moment where it drops to zero, that's usually where people tend to stick the rod. Once you create an arc gap, metal starts flowing and volts increase around 25 to 35 volts. Arc flow is the main problem with stick welding. Some corrections are to move the ground clamp to make sure it's got a good connection. Changing welding travel direction can help, and as a last resort, AC power could be a choice because with AC machines, current changes direction too fast for arc flow to happen. This page covers power sources. Moving on to joint preparation for butt welds. General rule of thumb, which I've already told everybody, is equal land, equal gap. The single V butt joint is one of the more common joint designs. Most pressure pipe and tubing require a bevel angle of 37.5 degrees, which gives you an included angle of 75 degrees. Lately, tacking is the main cause of failures for the Class A pressure test. Tacks must be equally spaced. 1/2 inch to 3/4 is a good size to shoot for. Most pressure tests will fail you for going over a 3/4 inch tack size. If you have a tack size under 1/2 inch, most likely it's going to crack. Here's a few more notes from that section. Welding variables. Arc length is usually equal to the core diameter. A shorter arc increases heat, which burns more rod, and a longer arc decreases heat and increases resistance, and it gives you all sorts of other problems too. Starting with the root, keep your rod jammed in where the land area is. Keep track of both sides of the joint and try to weld from tack to tack. Or later on, with a little practice, you can feather tacks out and burn right through them. The root pass is more brittle and prone to cracking. It absorbs carbon from the base metal. It cools much faster because it's a smaller weld. The hot pass is done to lock in the root pass by cleaning and fusing the toes of the welds. It's best practice to weld the root and hot pass without leaving it too long. If you leave it too long, there is a time where you could possibly get shrinkage cracking. The rest of the joint is pretty much the icing on the cake. Make sure it's clean. Wide weaves increase the heat effective zone, which can reduce the strength and make the material brittle. The fill pass should be almost flush and with no high or low spots before capping. So if you have high spots before you cap, you'd grind that all to the same circumference. To the ASME code, which you guys will be welding to, the max size of reinforcement is 1/8. Here's some more notes. This here is the last section, and we'll start with defects that's on your test. There's only 2 of them. Porosity, there's many different types. Porosity reduces the overall strength of the weld and is caused from atmosphere entering the weld zone. Another cause is moisture, whether it's in the filler rod or the base metal. Bad welding techniques and flux missing from electrodes can cause porosity, as well as dirty base metals with oils and whatnot on them. Undercut, this one here you guys know all about. It's usually from a crappy welding technique and from welding too hot. Feathering your tacks promote complete penetration at each tie-in. Low hydrogen electrodes, also called basic, also called F4 filler material, can absorb moisture. This is why they are kept in an oven at around 120 degrees Celsius. The exposure time for 7018 is 2 to 4 hours, and 9018 limits out at 2 hours. The 4 pipe joint positions, 1G rolled, 2G, 5G, 6G fixed, are important to know for your test. Here's the last summary. The test for this is 30 questions. We'll see you on the next one.